Assalamualaikum and good morning. Today my team and I is going to present our assignment presentation. Next, there is two of us. The first one is Jenny, which is me. Second one is Seti. And lastly is Saswani. Three of us will become the presenter for this group assignment. Now is our presentation content. First is introduction. Second is literature review. This both will presented by Saswani. Second is individual article summarized presented by Zeti. Lastly, synthesis and discussion presented by me.
My name is Nur Sasoni Sumerahmiti Ahmad. Today I will talk about introduction and literature review. For the introduction, this research promotes the eco-friendly use of fish bone waste, promoting the circular economy as seafood production increases. So this waste containing valuable calcium phosphate, CAP, and collagen. This can be transformed into high-value biomaterial like hydroxyapatite HA and beta-TCP, suitable for medical use such as bone graft and implants. Focusing on species like salmon, sea bream, and catfish, the study highlights global waste concern and suggests non-acidic extraction methods. It also offers natural calcium as a safer alternative to synthetic osteoporosis treatments. The literature review outlines current research on using fish bone to extract calcium phosphate and recover collagen. It compares conventional methods like calcination and acid treatment, which often sacrifice either mineral or proteins. For example, heat preserve mineral but destroy collagen, while acid extract protein but dissolve mineral. Newer non-acidic method using much saline solution now allow the co-recovery of both CAPS and protein like collagen, osteocalcin, and vimentin in active form. The review also highlights the advantage of natural CAP, which contain bioactive trace elements, and discusses modern techniques like ball milling and ultrasound that enhance calcium solubility and absorption. Additionally, it explores food applications, such as adding fish bone powder to baked goods and supplements, balancing nutrition with sensory drawbacks. Overall, the review supports the use of fish bone waste for sustainable and beneficial biomaterial production.
My name is Zeti Amberlisa and I will be covering the individual articles summaries, which are 10 articles we have chosen and researched through from Science Direct and also other websites. So the first study that we will be talking about is the calcium extraction from catfish fish bone powder, which is written by Manok Sri Uta, who is one of the authors for this study. This study focuses on optimizing calcium extraction using microwave assisted digestion. The catfish head bone powder, they actually made them themselves, was used with citric acid as the solvent. The process was successfully optimized using response surface methodology, also known as RSM in short. Unlike traditional methods, this approach also studied the interactive effect of four factors. The method was effective and well justified by the authors. Next is another study which is written by Amar Z. Al-Shamari, who is also one of the authors for this certain study. And the title of the article is Extraction and Degradation Rate Analysis of Calcium Phosphate, which examine calcium phosphate extraction from fish bones of carps and Atlantic bonito. This study focuses on hydrophysipatite extraction, structural analysis, and degradation rates. The hydrophysipatite extraction is one of the compound in the fish bones. As for the technique, they use three different kinds, which are XRD, FTIR, and SEM, to confirm the crystalline and porous structures. Next, they found that carp-derived hydroxyapatite degrades the slowest, showing species-dependent rates, and as a result, supports fish bones as a sustainable biomaterial source with tunable properties for medical use. On to the third one, which is a comprehensive study of diverse techniques by Chotsana Sriket. And this study focuses on extracting calcium from hybrid catfish bones. And just like the first study, this also uses microwave assisted method and also use citric acid as a solvent, which they achieve 1.11 mg Ca per milliliter under optimized conditions. The structural analysis confirmed that hydroxyapatite bound to protein. The extracted calcium was effective in producing alginate hydrogel beads, and in this findings, it support its use as a functional and sustainable material in food and biomaterials, which is quite similar to the second study that we had talked about. And for the fourth one is a physical chemical characterization of natural nanocalcium, and it's written by one of the authors, which is Sri Fatmawati. And this study, it focuses on nanocalcium extraction from croaker fish bones, also known as D-albida, albida, and O rubber. This study, it does not use the same methods as the other um, studies we have written. They use a thermal processing by using alkali treatments, and the particle size is 154 nm for the albida and 337 nm for the O rubber, both with high crystallinity of 74 to 78%. And in this study, it identified as calcium deficient hydroxyapatite suitable for biochemical use. As for the techniques, they use SEM, EDX, and FTIR to review the porous nanostructures with key elements and functional groups. Zeta potential of 34 MV and 39 MV indicated strong colloidal stability and osteogenic potential. This is where it's in within the bones. The thermal analysis showed high stability up to 800 Celsius with over 75% mass retention. The D-aldiba was the superior source due to higher calcium yield, smaller size, and better properties. So that means that D-albida is a better option rather than the O rubber. And in these studies, it supports fishbone waste as a source of valuable biomedical nanomaterial. Like the other studies, it also states that the fish bones is a useful source for biomedical stuff. On to the fifth one, which is the effects of catfish bones powder on consumers' liking, which is written by Sylvia Murillo. And this study tested by adding catfish bones powder or CBP with 21% calcium into breeding at 10% and 20% levels. A consumer panel N equals to 211 rated CBP samples similar to control in taste and overall liking with 20% mix rated crispier. Positive emotional responses include terms like adventurous and understanding for CBP samples. After being told about calcium benefits, purchase intent rose from approximately 72% to over 83%, especially among Latin Americans or Hispanic consumers. The instrumental tests among showed no negative effects on color or texture. The bone powder met food safety standards for heavy metals, and it concludes that the CBP is safe, acceptable, and effective food ingredient for calcium fortification. Next is the study of preparation and characterization of nanoparticles calcium oxide by Muriati. This focuses on synthesizing nanoparticles calcium oxides or NCO from snakehead fish bones SFB waste. This use a completely different method, which is the two-step process called calcination at 900 degree, followed by high energy ball milling. And this uses a FTIR technique to analyze the hydroxyl, carbonate, and phosphate functional groups. It also uses XRD techniques to review the average NCO particle size of approximately 39 nm, and they use SEM techniques to show the uniform granular nanoparticles, and NCO is seen as a promising precursor for hydroxyapatite synthesis, which on to the next study, we will move on to the fish bones of as calcium source, bioavailability of micro and nanoparticles, which is written by Benjamin Torres. And in this study, they compare the micro and nanoparticles of a salmon bone. And for the micro is approximately 10 micrometers, while the nano is approximately 0.25 micrometers. And in this study, they tested calcium bioavailability in young mice fed with 0.5% and 1.0% calcium diets. The nanoparticles showed the highest female calcium content with 15 to 20% higher bioavailability than calcium carbonate. The microparticles offered smaller improvements, which is 3 to 8%. Results confirm that smaller particle size improves calcium absorption, and the fish bones nanoparticles are more effective than traditional supplements and promote sustainable fish waste utilization. And for the last study that we will be talking about is the elemental composition, physico-chemical properties by Umesh Patil. And in this study, they compared the calcine gill powders from Asian sea bass or SBCGP and CatFish, which is CFCGP. Both powders were identified as calcium phosphate minerals with phosphate and hydroxyl groups. The Asian sea bass had finer particles and higher crystallinity, while the catfish had more organic matrix content. And for the morphology was porous and irregular, suitable for bone tissue applications. Both are promising for biomedical and nutraceutical calcium supplements, with sea bass powder showing slightly better properties. So in this case, is the Asian sea bass is much more better when it comes to biomedicals rather than the catfish.
Now I will present the synthesis and discussion part with summary key findings about calcium extraction from catfish bone and other related studies. Catfish bone are proven to be good natural source of calcium, especially calcium phosphate, which is important for bone health. There are a few methods used to extract calcium. First is thermal treatment, which produce biocalcium powder. Second is acid-base reaction. And lastly is ball milling, which create nano-sized calcium. Study compares catfish bone to mackerel and snakehead fish. The result shows that catfish bone have equal or even higher calcium content. Calcium from fish bone has higher bioavailability, especially when it is fine powder form or when combined with gelatin or collagen. That means it's easier for our body to absorb. Besides calcium, fish bone can also be used to produce gelatin. Some studies managed to extract both calcium and gelatin, which support zero waste and sustainability. However, there are some challenges. For example, there is a lack of standard methods. Most studies are small scale and safety testing is still limited. In conclusion, extracting calcium from catfish bone is eco-friendly and has great potential, but more research is needed for safety, large-scale production, and practical application. I think that's it from us. Thank you for taking time listening to our presentation. If you have any question or feedback, I'd be glad to hear them.